So in this video, I am going to go over integration with, or integration by trigonometric substitution. And I've seen a lot of people have trouble with this, and I've seen it taught by a few different people in a few different places. And a lot of the times, it's taught in a really, I don't want to say wrong, but bad way. Um, Like they'll tell you to just remember these substitutions, and sometimes they can seem completely arbitrary. And a lot of the times people have trouble thinking, where does this come from? So here's a way that I was taught, and I think it's the best way because uh, it involves no memorization. It's just completely logical. You can always figure out what to substitute with, and there's no trouble. I've been using it for like years, and it's the best. All right, so let's see. I feel like the best way to show this is to just do an example. So let's see. We got integral, and we're gonna. What is this? Let me just write this down. It's gonna be the square root of 25x squared. Oh, bear with me for 1 second, and okay. Damn it. Okay. Minus 4 over x dx, and this kind of looks scary. A lot of people might be like, how do I do this? So, um, one thing is when this term sort of waves the red flag that you need to do trigonometric substitution. If the problem just said evaluate this integral and that's it, didn't tell you to use trigonometric substitution, um, pretty much this again is the red flag. This top term, you got the square root of either the sum or difference of two squares, and now here we'll do a little aside. Everyone knows that Pythagorean theorem is this: a squared plus b squared equals c squared. Now, what does this form of this top term represent? It represents um, solving this for one of the legs. So if we do that, let's say we solve for a equals the square root of c squared minus b squared. You see that? See how they're the same? So in our case, let's do a new line. C squared equals 25x squared, so c equals 5x, and b equals 2, because b squared is 4. So this is the logic behind this technique, or this method, is that you take this information, you say, all right, well, one of the legs is this square root equals one of the legs, and the hypotenuse is 5x, and the other leg is 2, and you have a choice to which one you choose. And here's what I mean. Here's an image of a triangle, and from this, c is equal to 5x, so we put 5x in the hypotenuse area, and one of the legs is equal to 2. It can either be this one on the right, or it could be the bottom one. Either one works. Let's see. This would be your theta. I'm in Paint, so pretend that's a theta. So that's your theta down here. So we know that. Maybe I can do a little. There we go. So now basically from this you make any sort of relation you want, and now we know that this leg down here is going to be the square root from this whole logic up here. So we want an expression for x, because we want to substitute x in this expression with the expression for theta, because that's the ultimate goal. So let's see, from this we see that the sine of theta is 2 over 5x. So let's just So the sine of theta equals 2 over 5x. And if we solve for x, let's see, well, 1 over sine is cosecant theta. And that's equal to 5x over 2. And then you bring the 2 over, divide by the 5. Alright, so x is equal to 2/5 cosecant theta. So, that's our substitution. 2/5 cosecant theta. And we'll take this up here, and we'll replace x by 2/5 cosecant theta. It's going to look a little crazy, but I'm going to show each step just, because equals that. And, well, when we put this square through, it's going to be cosecant squared. This is going to be 4. This is going to be 25. And then we got the 25 down here canceling with the 1 up here. So that's 4. Let's just take this out. There. And then this will become a 5/2 up here. Okay, so for the next step, we can factor out this 4 as a 2 from the radical. Oops. And now as a little aside, we know that cosine squared theta plus sine squared theta equals 1. And if we divide that expression by sine theta, we get cotangent squared theta plus 1 equals cosecant squared theta, because 1 over sine squared theta is cosecant squared theta. Now we just move this 1 to the right hand side, and I'll just do that right here because I don't want to start a new line. And there we go. This is the same as in the radicand, so we know that inside the radical it's cotangent squared. And this is just algebra. So, well, cotangent squared square root is just cotangent, and then cosecant is 1 over sine, but it's in the denominator, so this is really sine. And then, well, cotangent is cosine over sine, so cosine over sine times sine is just cosine. Now, we're not done because we still have an x. We don't want an x. We have that dx. We have to replace all the x terms with theta. So, how do we get an x? How do we get rid of this? Well, we go up to our x expression right here, and we just differentiate both. We differentiate it. And we'll solve for dx. So if we do that, we'll get dx d theta equals 2/5 derivative of cosecant is negative cosecant theta cotangent. Oops. Cotangent theta. And now dx we quote unquote multiply by both sides d theta. Now, alright, so this is our dx. Our dx is this expression right here. Really important to do this. A lot of mistakes. People forget to get the dx. So we replace this dx. Oops. Now, let's just start it. No, let's do it right here. Replace the dx with this, and we see that the 2/5 cancels with the 5/2. Negative goes outside. We'll bring the 2 outside as well. And let's just bring this out of the parenthesis. So we have, well, let's see, cotangent times cosine. No, cotangent times cosecant is, oh, okay. cosine and cosecant is cotangent, and then cotangent and cotangent is cotangent squared, obviously. So our integral, this integral boils down to -2 times cotangent squared theta d theta. So now we just, well, we can use our expression we had before this. We'll just replace it with cosecant squared theta minus 1. And we'll do that right now. And that's integral, and we have -2 d theta. So, I'm going to put that negative through because, I don't know, it's going to screw me up. So, this is equal to negative, well, what's the integral of negative cosecant squared? Well, let's see, the derivative of tangent is secant squared, and that means that the derivative of cotangent is negative cosecant squared. Perfect. So this is actually just 2 cotangent theta plus 2 theta, because the derivative of 2 is theta. And plus c, of course. So this is the answer to our integral, but it's in terms of theta, and we need it in terms of x. That's actually no problem, because we can find out what cotangent is from our triangle we drew. And we said that this leg down here was equal to the square root function right here from the beginning, the top one. So cotangent is, let's see, over that, so it's going to be the square root. It's adjacent over opposite, so it's the square root over 2. So it's going to be this, putting it in terms of x. So it's this over 2, and I'm just going to write 1/2 that. But there's a 2 in front of it. It's 2 cotangent, so that goes away. And then, now what's theta? 2 times theta. Well, we go back to x and we just solve for theta. Actually, I'm going to bring it down here. So we have that. If we solve, we have cosecant theta equals 5x over 2. And then we have arc cosecant. It's not even a function in my math type because nobody uses arc cosecant. But let me just write it right now because, yeah, arc cosecant 5x over 2. Yeah, nobody uses arc cosecant. So basically, this is equal to the angle of our triangle. And so, and this is a new triangle. This isn't this triangle. Cosecant. The cosecant and secant I always have to think about for a second. Cosecant is 1 over sine, which is hypotenuse over... Oh yeah, it is this one. My mistake. So cosecant is 5x over 2. And we want to change that into either arc sine or arc cosine. And, well, sine is 2 over 5x. We know that from before. So sine of theta equals 2 over 5x. So then theta is equal to arc sine of 2 over 5x. And there we go, that's our theta, and we plug it in here, and there we go. Well, let's just write the full thing here. Equals, bam, oh, plus c. Oops, plus c. There we go. And that's the answer. So yes, most of this video is integration, the actual integration, and not like the trick to get to the integration. But basically it boils down to, you see the square root, you compare it to the Pythagorean theorem, You put it in a form that it matches, and then you just make the triangle. And from there, you find an expression for x using sine or cosine or tangent even, and do some derivatives to get dx, and you just plug it in and do the integral. And that's really it. This was my first math video, actually my first video on my channel. So if you liked it, do all the things people tell you, like, subscribe, what have you. Thanks for watching.